We mentioned before, like a few videos before this. Okay, so this one we protect the ketone with the ethylene glycol. Okay, this one we call acetal formation. You can do deprotect, remove this group. We call this hydrolysis. Okay, so of course, that's a mechanism as well. All right, so we're going backward basically. So we're gonna look at the mechanism of hydrolysis of all this acetal, imine, and enamine. Okay, just a little bit more. So acetal, the cyclic acetal you saw earlier, stable under basic condition. Okay, if you wanted to remove it, you add small amount of acid, and this guy will pop off, like the protecting group. Okay, and since all this reaction, we adding water. Okay, adding an acid, so proton source is hydronium ion, and the nucleophile is water. Okay, let's start with the acetal. Okay, hydrolysis of acetal. All right, mechanism goes like this. So when you go forward, we're gonna track backward, almost identical. Okay, so we'll start with an acetal. Okay, so we'll have the dimethyl acetal look like this. Okay, when you go to hemiacetal and go all the way back to acetone. All right, so added acid, of course, the first step, protonation on one of them. All right. Now this guy gonna leave. We're gonna kick this out. Use the lone pair on the other oxygen. Here we go. Kick that out. Okay. Right here, there's no depronation, no proton to depronate. We're gonna go to hemiacetal. To make hemiacetal, you need to add an OH group. See that? So we have to add water. So water comes in and attack. This guy is reactive enough. Okay. All right. Right there, you should recognize that. That's a strong acid. So depronation. Proton transfer, and that hemiacetal. Okay, halfway now. All right, from hemiacetal, so we're gonna kick the methoxy group out, so we're gonna pronate that. Okay, and then kick them out, use the lone pair on the oxygen OH group, and followed by depronation. That's it. Okay, we almost like we going backward basically. Okay, you can compare it to the acetal formation mechanism. It's almost identical, but to go backward. All right, go to imine. Okay, so on imine, we're gonna go to acetone. So this one gonna get cut, CN double bond. So water should attack that. All right. The first step, protonation on the nitrogen. Okay, then take water attack, just similar to the previous one you saw earlier, like the hydrolysis of acetal. Okay, all right, right here, deprotonation on the strong acid, so the hydrogen of the oxygen, and that's carbinolamine halfway. Okay, all right, we're gonna kick out the nitrogen, so we have to pronate it. So pronate that nitrogen. Here we go, and then kick it out. Use a lone pair on the oxygen. Last step, you should recognize that a strong acid, deprotonation. Here we go. Okay, all right, this imine. Compared to the imine formation mechanism, we track back the every single step. Okay, almost identical, going backward. All right. Now, enamine. Here's a little trick. So a little bit detail on for enamine. Okay. Well, in enamine, of course, the CN bond is gonna go right. Oxygen gonna attack on that carbon. Okay. But not only that, that's a thing you have to see. The last step to form enamine, if you remember, is elimination, right? So we have to reverse that. So let's take a look. We have 2 hydrogen on that carbon, but in the product, there's a 3 hydrogen. So the first step is a protonation. Put the proton back on that carbon first. Okay, that's gonna be the first step that we have to do. All right, so take protonation right there. All right, get ready. Let's go. So we take hydronium ion. So protonation here, right there. So you get 3 protons on this carbon now. Okay, you can draw a resonance structure right here. Not required. All right, take water. So water attack. Okay, you can see the deprotonation of that water, so you get the carbinolamine halfway. All right, the rest are just the same. We want to kick the nitrogen now, so pronate that. Okay, kick them out, use the lone pair on oxygen, and then followed by deprotonation. That's it. Okay, so all 3 reaction, it just one. They're very similar. All right, let's predict the product. Okay, let's go to the next video.